Yeah. Hello, students. Welcome to Embed Pathashala. In the previous lectures, I have shown you what is Linux system programming and how to execute the code, basic compilation stages that are available in programming, right? So in this video, I will explain you about different memory regions that you will be frequently hearing in system programming terminology or in your embedded domain. So let's begin this course. So in programming, when you are writing, you will always hear some terminology called text segment, data region, BSS, stack, or heap. Like these are the terminology that we will be basically using in your development activities. So now let's understand step by step, like what are these different memory segments means. So first, before going into segments, you need to understand one concept called process memory map. That means, in the previous lecture, I have said that whenever a program is in execution, that particular instance is called as process, right? So, for the process to run, we need some memory, and that memory is allocated based on the process execution. So, what OS does is your kernel or OS, it allocates some block of memory for a process to handle its activities. So while giving that memory, it cannot simply give some block of memory and ask the process to do whatever it wants, right? So it need to divide that particular memory region which is allocated into some segments. So process will understand where to store what data. So that organization of memory is called as memory map, and each process that is running will be allocated with its memory map from the virtual address space. We have seen what is this virtual address space in the previous lecture. So this is how it will work. So the memory map is assigned to process will contain these sections: stack segment, heap segment, BSS segment, data segment, and text segment. So basically, now I will give you overview. Text segments mean code instructions. In previous video, in compilation process, I have shown you one stage where you will see machine code, right? We have seen practically. That machine code, the code instructions will be sitting in your text segment. Next, initialize data. In your code, whenever you initialize some variables with some value, that initialized will be sitting in your data segment. And any uninitialized values or variables will be stored in your BSS segment. Next, stack. Stack is for to store local variables or the function parameter, return calls, which are specific to one function. That things we will be storing in stack. Next, heap segment. Heap segment is used to store for dynamically allocated memory. So you are writing a program and you suddenly need some 10 bytes of memory. You will be assigning that memory from heap segment. This is the overview of different segments available in the process memory map. So in interview, if someone asks you what is a process memory map, you need to explain these things. Now let's go in detail. First, text segment or code segment. That means whenever your code is compiled, the machine instructions that get generated in the last stage of your compilation, that will be stored in the text segment. We call this text segment as code segment also. So don't get confused. Next, features of this code segment. It is read-only memory. That means you cannot write any data into text segment. Rule number one. Next, it is shareable. For example, if multiple instances of your program are running and everything shares the same text segment, it will not be generated again and again. This is rule number two. Rule 3 is text segment is always located at the lowest addressable memory of your memory map. So once a particular memory block is assigned to your process, the lowest memory map region, we call it as code segment. Hope you are clear with text segment. Now let's see about data segment and BSS segments. Data segment is used to store any initialized data of your program. For example, you have created a variable int a and assigned it value to 10. That assigned variables will be stored in data section. So here I want to bring 2 points. One is any initialized global variable will be gone to data segment. Any initialized static variable will also sit in data segment. This is the importance of data segment in your code. Next, BSS segment. Any uninitialized data, either it be global variable or it may be local variable, local static variable, these contents will be stored in the BSS segments because even though it is uninitialized global variable, its value will be assigned to 0. So it should be stored in BSS segment. And static variables, to preserve its functionality, we will be storing them in BSS segment. So this is the overview of data segment and BSS segment. Previously, we have seen what is text segment. So now I hope you are clear with text segment, data segment, and BSS segment. Text segment to store machine instructions, data segment to store initialized data, BSS segment to store the uninitialized data. Great. Now stack. So what is stack region in the memory map? Whenever a program is running, it will have some local contents that need to be stored. For example, a function call is getting executed. That is, all the parameters that are defined in that particular function are valid only till that function is executing. After that, it has no use. So such kind of things like local variables, this function parameters, and the return address, these are local, right? Once execution complete, no need to use them. So these things will be stored in stack frames. Next, scope of the stack. So once stack region is created, what should be the lifetime of that particular region? So this scope of stack is, it exists only till the functions is running, because stacks are allocated based on this function calls execution. So once the execution of function completes, the stack memory region will get cleared off. This is the important thumb rule for stack. And growth. So stack always moves from higher address space to the lower address space. So once a memory map is assigned, the higher address space stack start and it grows towards the lower address space. Execution in stack is always faster because here simply we move pointers from one address location to other address location. So execution of the stack is faster. So these are the concepts related to stack. Now you are clear with data segment, heap segment, text segment, and stack region, right? Now important, heap region. Great. No. So when you are writing program, assume you thought initially like 10 bytes are needed for my program to execute, whatever, to store some variables or anything. Later you understand I need five more bytes to store some more data. At that time you cannot change, you cannot go back and change where you allocated memory, right? For example, you created int array of 5, assuming you need 5 values to be stored. Later, you understand, okay, I need to add 10 more values. So at that time, you cannot go back again and write 10 bytes over there, right? To handle such kind of scenarios, we have a concept called heap memory. That means while writing the code, no need to declare previously. Here, what you will do, now you feel like you need 10 bytes of memory. So you will simply allocate memory dynamically stating I need 10 bytes, and you will get your 10 bytes of memory from this heap section. You write the code and you are done with your things. Then you can free that memory and it will be used by someone else later. Also, you For example, you thought um, you are writing a code using simple arrays. You assign 100 bytes of memory thinking you need to store some 100 values. But in real time, you only need 10 values to be stored. That means memory of 90 values got wasted. In such scenarios also, you can use your heap memory to allocate memory dynamically. After using the heap, you can simply free the memory. This is the functionality of dynamic memory allocation. And all the dynamically allocated memory will be stored in the heap section. That. Next. This is a practical C example where I will demonstrate you different segments of memory. So what I did here is I have created one global variable and initialized it with value 10. I, as it is global variable and initialized, it will be stored in the data segment. Second, here also I have created one global variable, but it is not initialized to any value. That's the reason this will be stored in your BSS segment. So this is data segment and this is why it's stored in BSS segment. Now, assume it came to main function. In main function, I am allocating some memory dynamically of 4 bytes. Okay. So this memory will be assigned from heap section of your memory map. Done. Now you call some function. So function call executed and a particular stack frame will be generated for this one. In this function call, you see first variable is static variable. So this need to be stored in your data segment. And the second variable, which is local variable, so it is only limited to this function call. So this is stored in your stack memory space. Similarly, any variable or anything that is local to this particular function will be stored in the stack section. Any function parameters or any return variable, whatever it is, which is related to local of the function, they will be stored in stack memory space. Done. After function call, we will come back here. We will clear this dynamically allocated memory. We will free the memory so others can use and we will return. So this code execution completes. So when a program is running, this is how your memory, your variables are stored in different segments of the process memory map. This is the concept. Now, let's see one example in our terminal. So here I have written a code where what we have seen till now, different data segments I have created and I have stored. Now we will run this one. So program to compile the code is gcc -o, output name mem underscore map, and the source file name mem underscore map.c. So compilation successful. Now if you see, one output file which is called memmap which we have given is created. So we need to see how much size it occupied. So for that we will give command size mem underscore map. So this much memory it has consumed. For now, you don't think much about this text and data because you will not understand if I say now. Let's only concentrate on BSS. If you see here, we have stored two variables, right, in BSS segment initialized. That is the reason it is showing 8 bytes, which is 4 plus 4, 8 bytes of memory. This is how when a program is executing, memory will be allocated in your process memory map. So that's it, guys. This is how you should you mean this is the overview of memory concepts. In interview, if anyone asks you explain about the memory regions or process memory map, this is what you should explain them. And this is how, if they ask you to write code and demonstrate, this is the one thing that you can show. Hope you are clear. Now let's give some summary of what we have learned. We have seen different regions that exist: text section, data section, BSS section, heap section, and stack section. And content. So text segment contains binary instructions, the code instructions. Data will contain initialized and static variables. BSS will contain uninitialized global variables. Heap segment for dynamic memory allocations, and stack for local variables and return address. This is the concept. So lifetime, yeah, this is very good interview question for freshers. The interviewer might ask, tell me the lifetime of each memory segment. Then you should tell text segment is valid till program execution. Data segment is valid till program execution. BSS segment is also valid till program execution. Heap segment is user control. When user allocates memory, it will be allocated, and when user frees the memory, it will be deallocated. And stack frames are local to the function scope. Whenever the function completes its execution, stack frames will get deleted. And access permissions for this segments is text is read only segment and you cannot do any modifications there. Data segment, BSS, heap, and stack, all these memory sections are read and write. That means you can read data from here, also you can write data into this memory regions. This is the summary of complete process memory map. Yeah, that's it, guys. Hope you are familiar with different memory segments in the process memory map. If you have any doubts, please post the questions in the group chat and I will get back to you. Okay, thank you.